Okay, hello everybody. Today we're going to go over section 8.2. 8.2 is about the polar coordinate. So you already know what is a Cartesian coordinate plane. So this is what you have, the x-axis and the y-axis. We're quickly reviewing what you've studied in algebra. So here are the positive x-axis, the negative x-axis, positive y, negative y, and we know how to plot points. For instance, 2, 3 has the x-coordinate of 2 and a y-coordinate of 3, and here's our point, 2, 3. And this point here, you have negative 1, 2, so x is negative and y is positive 2. So you know how to plot points in the Cartesian coordinate plane. Now, how do we plot points in the polar coordinate plane? So let's see. What are the polar coordinates? The polar coordinates labeled r theta. R theta. R is your radius and theta is your angle. Okay, so how do we plot a point in the polar coordinates? So let's see. Let's take a look. Here you have what we call the pole. Okay, and these are going to be your angles. So here you have is pi over 2. Here you have pi, right? Here you have 3 pi over 2. You can here have pi over 4 is right in the middle here. Between 0 and pi over 2, pi over 4. And so on. So this is 3 pi over 4. Okay. And so on. So the angle, here you have them, pi over 4, pi over 2, 3 pi over 4, and pi. But what about the radius? Well, radius is r. So this is, let me go ahead and graph it a little bit. Try to make it as even as possible. Okay, so this is R1, R2, R3. So the second radius, the second circle would be R2, R equal 2. The third circle would be R3. The fourth circle would be R4. So let's go ahead and plot a point. So let's plot 3 pi over 4. So this point right here is a polar coordinate, right? Point. So we need to plot it. The radius is 3 and theta is pi over 4. Here's theta, pi over 4. Radius is 3, so the third circle. 1, 2, 3. That point right here would be this point here. 3 pi over 4. Okay? So let's go ahead and plot another one. So suppose I ask you to plot 2 and pi over 6. So let's go ahead and do this. Here's your pole. This is pi over 2. Here's pi over 4. Pi over 6 is here. This is pi over 4. And you have the first radius, the second. So r is 2 and theta is pi over 6. So here's pi over 6 and here's 2. That's a point right here. Okay. So let's go ahead and plot some more points in here. So let's plot now negative 2 pi over 3. Now the radius is negative. So how do we plot that? Well, so let's take a look. Here is your pole. This is pi over 6 here, pi over 4, pi, this is pi over 2, so pi over 3 is roughly around here. And let's go ahead and graph the two circles. So this is here is going to be pi over 3, and this one would be here 4 pi over 3, right? Now, the theta is your angle pi over 3, but the radius is -2. So instead of going in this direction, negative, you have to go in the opposite direction. So here, you're going in that direction, pi over 3, but instead of going here, you have to go the opposite. Why? Because the radius is negative. So that point here is -2 pi over 3. Sorry if they're not equal. It's a little hard to graph. They're not even. Okay, so if r is negative, you go in the opposite direction. All right, so let's go ahead and plot a few points. So plot 3 pi over 2. So how do we do this? Go ahead and pause the video for a second, and let's go ahead and do this. This is pi over 2. So what would that be? It's going to be here, right? Pi over 2, and you have 3 circles. Try to make them even. So this is 3 pi over 2. Okay, so let's do one more with a -r. So plot -3 pi over 6. So what do we have to do? Go ahead and pause the video. Go do it yourself. When you're done, come back. So here's your pole. So again, pi over 6 here, pi over 4, pi over 3. So pi over 6 here. However, r is negative, so we have to go in the opposite direction, right? So this is pi over 6, and all of them, this is pi over 3, pi over 2, pi. So let's go ahead and graph 3 circles. So pi over 6, -3 is pi over 6, but r is -3. We go in opposite. 1, 2, 3. Here is your point right here, -3 pi over 6. And this is the way we plot points. Plot polar coordinates. Okay, now how do we convert between polar and Cartesian coordinates? Let's go ahead and go over that. So converting between polar and Cartesian coordinates, or rectangular, you know. We can say Cartesian as well. Okay, so what do we have? Let's see. So the point here would be, point here, for instance, xy. So what do you have? This is your y right here, the height. This is y. and this is right here is x. That angle right here is theta, and this is the radius r. Okay, so cosine theta would be what? Would be adjacent over hypotenuse, so x over r. That means x is equal to what? Multiply both sides by r, so this one times r and this one times r. The r here cancels. You'll be left with r cosine theta. Okay, and then if we find sine theta is opposite the angle, which is y, over hypotenuse, which is r. Again, if you multiply both sides by r, what we're going to have? So here we multiply by r, they cancel, and here multiply r, I'm just going to cancel, so y would be what? It would be y equal r sine theta. So this is a relationship between x, y, and r theta. Okay? So if you have a point in with a polar point where you know r and theta, you can immediately find x and y. Okay? So let's use an example. If we take a look at, let's see, we can go ahead and do number 3 from the book. So let me go ahead and get number 3 from the book, and we can go ahead and do it. So number 3. So this is a question: convert the given polar coordinates to Cartesian coordinates. Well, we know this is r and this is theta. Remember, in polar, r theta is your point. So now we can easily find the Cartesian coordinates. The Cartesian coordinates are what? Are x and y. So we need to find x and y. How do we do that? Well, x is equal to r cosine theta, right here. R is 4, cosine theta is 7 pi over 4. Now remember, where is 7 pi over 4? So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It's in here, that's 7 pi over 4. The cosine in 7 pi over 4 here, that's in the fourth quadrant, which is positive. So this is equal to cosine pi over 4. So that's 4 cosine pi over 4. 4 cosine pi over 4 is square root of 2 over 2, right? So this simplifies, and you're left with 2 square root of 2. Now let's go ahead and find y equal r sine theta. R is again 4 sine theta, sine 7 pi over 4. Now it's in the fourth quadrant, the sign is negative, so this is the same as negative sine pi over 4. Remember the reference angle? So that's 4 times negative sine pi over 4 square root of 2 over 2. So 4 divided by 2 is 2. 2 times negative square root of 2 is negative 2 square root of 2. So this is your y and this is your x. So what is that point in Cartesian coordinate? How can we convert it? It's 2 square root of 2, negative 2 square root of 2. And we were able to convert it using this relationship between x and y. Okay, so I didn't give you all the relationship between x. So we have two other formulas that we can use. Okay, so these two, we use them when we want to convert from polar to Cartesian, but there are other two formulas that we can use. Let's take a look. Here is a 90-degree angle, right? So this is a right triangle. Remember, the legs, the sum of the legs squared, a squared plus b squared equals c squared, right? So we can write it as x squared plus y squared equal r squared. Remember, this is a right triangle. So this is x, this is y, this is r. A squared plus b squared equals c squared. So x squared plus y squared equal r squared. And this is theta, so you can also use, let's just say, tan theta would be what? Isn't it opposite over adjacent? So tan theta is y over x. Okay, so we use these two formulas if we have r and theta, if we have a point in polar coordinates, so we can immediately change to x and y to convert the point to Cartesian coordinates. But if you have x and y, you want to change it to polar coordinates, we use these two. X squared plus y squared gives me r squared. You take the square root of that, and we get the r part of the coordinate. Okay, so remember that, and tan theta is y over x. I can use the y and x in the Cartesian coordinate to find theta, and theta would be tan inverse that, unless it's a common angle, so you can figure it out. A lot of times they're going to be common angles. Sometimes we are not always, but a lot of them are going to be like that. Okay, so these are used to convert from Cartesian to polar, and these are used to convert from polar to Cartesian. So these are the four formulas that we'll be using. Okay, so we need to now convert another polar coordinates to Cartesian coordinate. So again, what is this? Remember, the Cartesian coordinate, the polar, this is r and this is theta. How can we get the Cartesian coordinates? Now remember, x is equal r cosine theta. So r is -3 cosine theta. Theta is pi over 6. So -3, we already know what cosine pi over 6. Remember, root 3 over 2. Sine pi over 6 was 1/2. Cosine pi over 6 is root 3 over 2. So this is -3 root 3 over 2. Now let's find the y coordinate. It's r sine theta. So what does that give us? R is -3 sine pi over 6. So -3 sine pi over 6 is 1/2. So this is -3 over 2. So this in Cartesian coordinate, x is -3 root 3 over 2, and y is -3 over 2. They're both negative because the angle in the first coordinate, so the cosine and sine are positive, but r is negative, so they're both negative. Okay, so this is number 9, converting polar to rectangular or Cartesian coordinates. So now let's use other examples from Cartesian to polar. So now we're going to do number 9, convert the given Cartesian to polar coordinates. How do we do that? Okay, so we know that this is Cartesian, so x is equal to 4 and y is equal to 2. Well, first, if we want to know how to find r, what do we use? It's x squared plus y squared equal r squared. If you can't remember it, here it is. Here's theta, and this is the point xy, and it's also r theta as well. So here is y and here's x, and this is r. So to find r, what do we have? X squared plus y squared equal to r squared. X squared is 4 squared plus 2 squared equal r squared. So that means what do we have? 16 plus 4 equal to r squared. So r squared is equal to 20. That means r is square root of 20. You can simplify it. This is 4 times 5. So r is 2 square root of 5. We know r, right? Now we need to find theta. Now remember, we use the formula, you know how to find the tangent, right? Tangent theta is y over x, right? We already know what y is. Y is 2 and x is 4. So tangent theta is equal, simplifying it, as 1/2. Now theta here is not a common angle. It would be if this is sine or cosine, but not for tangent. So in order to find theta, what do? We use the tan inverse, 1/2. So go ahead and get that. And let's see. So we have what? Tan inverse 1 over 2. So that's what? 0.4636. So 0.4636, and then making it into 5. So we have it. This is theta. So now we have theta here. Now take a look. Where is 4 and 2? Where would that be? This must be where? This must be in which quadrant? This must be in the first quadrant. Why? Well, graphing it, x is 4, y is 2, so it's in here. That point here is in the first quadrant. Since this is in the first quadrant, this is the answer that we get is in the first quadrant. Remember, to find the angle that's equal to a number, it's usually in 2 quadrants. In this case, we don't have to look for the second one because the point itself in the first quadrant. So this would be our theta. So what is our theta? That's a point in polar coordinates, and that would be in r is 2 rad 5. Theta is 0.46365. So this is the point in polar. All right. So let's have more examples. So this is number 13. Let's have another example. So this is another example, number 15. Convert the given Cartesian into two polar coordinates. So again, x is equal to -4 and y equal to 6. I want to remind you this is in the second quadrant. Okay, so let's go ahead and find r. What is r? So remember, x squared plus y squared equal to r squared. You can write this before if you like to. So -4 squared plus 6 squared equal to r squared. So that means what do you have? R squared is equal, I'm writing this one first. -4 squared, that's 16, plus 6 squared, that's 36, right? So r squared is going to be, you just add them up. You got, what is that, 52? 36 plus 16 is 52. And we don't care about r squared, we want r. So we take the square root of 52. So 52 is not 4 times 13. So 4 comes out as 2 rad 3. So we have r. And now we can find theta. Okay. So theta here is in the second quadrant. Second quadrant. So this is between pi over 2 and pi, isn't it? That's your second quadrant. So tangent theta, let's see, y over x. This is not going to be it. This will give us an answer. That's the reference angle. But we'll start with that. So tangent theta, y is 6 and x is -4. So this is what? Divided by 2. Divided by 2, that's 3 over 2. So theta is tangent inverse -3 over 2. But this could be what? The reference angle. Okay? Tangent theta is going to be what? You're going to add to it what? If you evaluate that, what is that going to give you? It's going to give you -9.8279. So the angle is negative. Okay? So how do we get this? So theta is going to be approximately -0.98279, right? So again, this is not our angle, because our angle, this is not in the second quadrant. So you're going to add to it where? It's going to add to it pi. Okay, so remember, this is going to be here. This is -0.98279, and you add to it pi, and this will be in the second quadrant. You add to it pi here. So the angle, you add to it pi, and that will give you what? 2.1588. So 2.55188. So the angle that we want is approximately 2.1588. Okay? Remember, I'm going to put r here for reference angle. This is a real angle. So our point here, r is 2 rad 3, and theta is 2.1588. This is number 15. Oh, I forgot the 3. Sorry about that. 13 here. See, 4 times 13, 4 comes out as 2. You have a 13 here, so this is 2 square root of 13. And theta is 2.1588. If you need more time, please take the time to do this problem. Okay, so we're going to do now number 29. In number 29, they ask us to convert the given polar to Cartesian equation. So if you notice, you have a polar equation. You have r and theta. We want to change it to Cartesian, one that you're used to from algebra with x and y. How do we do that? Well, we're going to do that using some of these formulas right here. Okay? So you want to get rid of the r and you want to get rid of the theta. How do we do that? Well, let's take a look. What do we have? We know that x is r cosine theta, y is r sine theta. X squared plus y squared equal r squared. Tan theta is y over x. What do we do? We cannot change sine theta into x or y. However, if this is r sine theta, what do we get? R sine theta is simply y. See what I mean? If I have an r here, I can change this. This becomes a y in here. And if this multiplied by r as well, this will be r squared. And that will give me what? That will give me x squared plus y squared. See what I mean? So we're going to be, if you were to multiply both sides by r, so this one would be r here, this one would be times r. What do we get? This is going to become r squared, and this is going to be 3r sine theta. Now, if you recall, x squared plus y squared is equal to r squared. So this becomes what? X squared plus y squared. And if you recall, y is equal r sine theta. So this one becomes what? Y. And here you have 3y. And I just converted the polar to Cartesian equation. Going back to algebra, what is this? Looks like this is a circle, but they didn't ask us to identify what it is. Okay, so what you're going to be doing in here when you convert from polar to Cartesian, Cartesian to polar equations, you're going to use the formula that you learned today. So let's try to do other problems. So let's do this problem. Let's go ahead and convert the polar equation to Cartesian equation. Well, first of all, we don't want this. We want to get rid of the denominator. So if you cross multiply, what is that going to give you? It's going to give you this times this equal 4 times 104. So r sine theta plus 7r cosine, 7 cosine theta equal to 4. Right? So now distributing the r, you're going to have r sine theta plus 7r cosine theta equal to 4. Now, what is r sine theta? We still have it here. That's a y. Plus 7. What's r cosine theta? R cosine theta is what? Is equal to, r cosine theta is x equal to 4. I just converted it into a Cartesian equation, x and y. And it looks like we have a line here. When you see something like this, if you can imagine, like if you were to multiply, this is going to be r sine theta, and you realize this is a y, and here 7r cosine theta, and that will be net 7x. So you can guess it. Usually when you have a fraction like this, cross multiply, get rid of the denominator. Either multiply both sides by the LCD or cross multiply like we have here. This is number 31. So let's have more problems. All right, so this is number 34. Again, converted to a Cartesian equation. If you notice, you have a cosecant. So if you can change it to sine or cosine, that would be great. And you know from cosecant, what is cosecant? Cosecant is what? Is 1 over sine theta, right? So that gives us what? R equal to 3 times 1 over sine theta. Or simply R equal 3 over sine theta, right? Cross multiply, what does that give you? Immediately you can see it. If you cross multiply, you're going to give us r sine theta. And r sine theta is y, right? So here you can write it as r sine theta equal to 3. And r sine theta is what? Y. And y equal to 3. That's a horizontal line. So you're going to have to figure out a way how you can change your equation into Cartesian equation. So let me give you, let's do one more. You can do it on your own. So here is another problem, number 35. Please pause your video and do this. Try to do this on your own. Okay, so go ahead, pause the video. Okay, so I hope you're able to do this. Again, you want to think of a way to change this to x and y. And I hope you're able to see that you can't do much here with square root. I guess this becomes r cosine theta is x, but there's no way, there's nothing I can do with this, with r. However, I think you're able to see that r squared is x squared plus y squared. So what would you have to do here? If you notice, if you can square both sides, you would get rid of two problems. You would get rid of the square root. I don't know if you want to call it problem though. You can still count it as x plus 2, but if you want to get rid of the square root, that's one way. If you square both sides, this becomes r squared. This becomes the square root here disappears. So that will solve this problem, and this will take care of the square root. So r squared is r squared here, and square cancels the square root. The radicand comes out as r cosine theta plus 2. We know that r squared is what? We know that this is x squared plus y squared equal, what is r cosine theta? R cosine theta is x plus 2. And here's your equation. This is your equation. Again, this is a circle if you want to. So this is number 35. All right, so now we want to convert a Cartesian equation to a polar equation, okay? So we have here x equals 3. How do we convert this to a polar equation? Again, using the same formulas here. We want to be creative. What is x? Isn't x equal to r cosine theta? So x here is r cosine theta equal to 3. So now we got rid of x, and now we have only r and theta. However, if you've seen the example that we just did, converting from polar to Cartesian, you notice in all of them they're given us equation in R. So it's a common way of doing this. No problem, we can do an equation in R. We can divide both sides by cosine theta, right? So, and then this gives me what? This would cancel, and R is equal to 3 over cosine theta. So we just converted a Cartesian equation to a polar equation. By the way, this is fine. You may want to as well write it as 3 over cosine. Wouldn't that be the same as 3 secant theta? Slightly more efficient here. Number 21. Please pause if you need more time. Okay, so we need now to do number 23. We can do number 23. How do we convert it to a polar? Now remember, y is r sine theta equal to 4. X is r cosine theta, right? So this is r cosine theta squared. Now simplifying this, r sine theta is equal 4r squared cosine squared theta. Again, so we want to solve for r like we did before. First you can divide by r if you like. Because if you divide by r on both sides, this is going to cancel, this become r. So this becomes sine theta is equal 4r cosine squared theta. So divide by r on both sides here. So we simplified it. This cancels and this left with r. Now we want to solve for r, so we want to get rid of everything else. So 4 cosine squared theta, and here 4 cosine squared theta, right? So that gives me what? This cancel with this cancel with this, so I have r on one side. I'm going to write it on the left side here. And here what do I have? Sine theta over 4 cosine squared theta. Now we can leave it like this, but if you notice here, that gives me cosine times cosine, and I have here sine divided by cosine. So if I rewrite this, take a look. Sine theta over 4 times cosine theta times cosine theta. So this gives me a tan, you notice? So I rewrite it as, whoops, the 4 is in the denominator. 4 is in the denominator here. Give me 1 second. So 1 over 4 sine theta over cosine theta, I'm separating them, times 1 over cosine theta. That's the same as you have here. So this gives me a tan theta, and this gives me what? A secant theta. So r is what? Tan theta secant theta divided by 4. Okay, so I just converted the Cartesian equation to a polar equation. So go ahead and see if you can do this, if you can understand. If you need more time to understand it, that's fine. You don't need to separate like this, but I'm just here to show you. You can rewrite this. It's not very, I guess technically it's correct, but it's not very efficient to leave it like this. Write it like this if you can. Okay? So this is one problem. Now I want to give you a problem for you to do this. Y squared equal to 3 minus x squared. So go ahead, pause the video, and do this on your own. Convert it into a polar equation. Okay? I'm going to start now. So, well, y squared, I know y is r sine theta, and make sure you square because that we have square, equal to 3 minus x is what? R cosine theta, and square that. Simplifying this, what is that going to give us? R squared sine square theta equal to 3 minus r squared cosine square theta. All right, so if I take this to the other side, if we add both sides, r squared cosine theta here plus r squared cosine square theta in here. Remember, we want the r's to be next to each other here. So what do we have? We have r squared sine square theta plus r squared cosine square theta equal to, this cancels, 3. Okay, I moved it over to the other side. All right, please don't divide by r squared. You're going to end up with r squared in here as well. So you're not done. So please take this to the other side. If you factor out the r squared, you're going to have sine square theta plus cosine square theta equal to 3. What do you notice? Isn't that equal to 1? So r squared times 1 equal to 3. That means r squared equal to 3. Solving for r, what does that give us? R is square root of 3. So this is r equals square root of 3. So please pause the video if you need more time. I'm going to go ahead and get one more problem from here. Okay? So one more problem here, number 25. Go ahead and convert this to a polar. So go ahead, pause the video. Okay, so I hope you were able to get this. There are about 2 ways you can do this. You can, if you want, to write x as r cosine theta, and here y is r sine theta, or you may have recognized that x squared plus y squared is r squared. You see that? X squared plus y squared equal r squared equal to 4. Y is what? Y is r sine theta. You divide both sides by r, you would get rid of the r in here. So that gives you what? R squared divided by r is r. 4, the r here cancel out, sine theta. So this is one way that you could do it. Or you probably did this. You've probably written this as x is r cosine theta square. Just a little bit more work. And y is r sine theta. square equals 4y is r sine theta. And simplifying this, what do you get? You get r square cosine square theta plus r square sine square theta equal to 4r sine theta. If you factor out the r square, what are you going to have? You're going to end up with cosine square theta plus sine square theta equal to 4r sine theta. So r square, remember, cosine square theta plus sine square theta is 1, equal to 4r sine theta. So r square equal to 4r sine theta divided by r. And what do you get? You get r equal to 4 sine theta. So you could have done that or this. Either or, they both work. But you may have noticed the x squared plus y squared equal r squared. So I'm going to stop the video here. See you next time. Bye.